Right now, in the quiet space around you, something impossible is happening. Tiny messengers are streaming into your eyes, countless, silent, and invisible in their journey. They have no mass, no size, no internal structure, nothing inside them at all. And yet, they are the very reason you can see, think, and experience this moment. These are photons. And tonight, we follow a question that has unsettled physicists for over a century. Not because it is complicated, but because it is too simple. What is a photon made of, if it is made of nothing at all? Every object you know has some kind of internal structure. Atoms contain nuclei. Nuclei contain quarks. Even the smallest particles we've studied often reveal layers, properties, or hidden dynamics when examined closely. But the photon refuses. No matter how deeply we look, no matter how powerful the instrument, no experiment has ever revealed anything inside it. It is not hollow. It is not solid. It is not composed of smaller pieces. It is simply there. Or perhaps more strangely, it is something that happens. If you've watched our earlier Vellerin journey into the quantum vacuum, you may remember how empty space itself is never truly empty. That same quiet foundation will guide us tonight, because the photon may not be an object at all, but a fleeting pattern within something deeper. And that idea opens a series of quiet, lingering mysteries. If a photon has no inside, what exactly is vibrating when light moves? If it has no mass, where does its energy exist? If it has no size, what does it even mean to say it travels through space? We will move slowly through these questions, not to rush toward answers, but to let them settle gently into place, one layer at a time. So as you relax, allow this thought to stay with you, something with no substance, no structure, no interior, is quietly shaping the entire visible universe. And before we continue, if you enjoy these slow cosmic mysteries, take a moment to subscribe to Vellerin's Sleepy Space Mysteries, leave a like, and turn on the bell so you don't miss future journeys. You can also join as a member if you'd like to support the channel more deeply. And as always, I'd love to know, where in the world are you listening from tonight? If a photon truly had something inside it, even the smallest hidden layer, the universe would have revealed it by now, not through theory, but through time. Because photons are not confined to laboratories or brief experiments. They are travelers on the longest journeys we can observe. Some of the light reaching Earth tonight began its journey billions of years ago, long before our planet formed, long before our sun ignited. These photons have crossed expanding space, drifted through clouds of gas and dust, passed near massive galaxies, and slipped through regions filled with magnetic turbulence. And after all of that, they arrive unchanged. This quiet consistency is one of the strongest clues we have. If a photon had internal parts, those parts would not all respond identically to the environments it encounters. Imagine a tiny object with layers moving through shifting conditions. One layer might slow slightly in a dense region. Another might react differently to gravity. Over immense distances, even the smallest differences would accumulate, stretching the photon's structure in subtle ways. But we do not see this. When distant cosmic events release bursts of light across many energies, those photons arrive together with remarkable precision. High-energy photons and low-energy photons, emitted at the same instant, travel across billions of light-years and still reach us almost simultaneously. There is no measurable delay separating them based on energy. That absence of delay carries a quiet message. It suggests there are no internal regions that can drift apart, no layers that can shift independently. The photon behaves as if it is completely unified, with nothing inside that could fall out of sync. This pattern repeats in another subtle way through polarization. Light can carry orientation, a kind of alignment in how it oscillates as it moves. When photons are emitted from distant galaxies or energetic cosmic events, they often carry a specific polarization pattern, like a gentle directional rhythm embedded in their motion. If a photon had internal structure, that structure would be vulnerable. As it travels, interactions with magnetic fields, plasma, and gravitational distortions would gradually twist or scramble its internal alignment. Over billions of years, even tiny disturbances would accumulate into noticeable changes. But when we observe light from the far reaches of the universe, the polarization remains stable. The pattern survives the journey intact, as if there is nothing inside the photon that can be disturbed or rearranged. Even in controlled environments, where scientists push photons into extreme interactions, the story remains the same. In high-energy experiments, photons collide with particles, scatter, and exchange energy. If there were hidden components within the photon, these interactions would occasionally reveal them through unexpected patterns or asymmetries. Yet every measurement aligns with a simpler picture. The photon responds as a single entity. No fragments appear. No internal behavior emerges. There are no signs of substructure being exposed under pressure. And perhaps most quietly convincing of all, photons do not decay. Many particles in the universe are unstable. Given enough time, they transform into lighter particles, releasing energy as they do. This process often reflects internal pathways, ways that energy can move through the structure of the particle and reorganize itself into something new. But a photon does not change. If left undisturbed, it can travel indefinitely. It does not break apart. It does not transform into something simpler. It does not reveal hidden states waiting to unfold. It simply continues. This persistence suggests something profound. A photon does not contain internal configurations that can rearrange. There are no hidden modes of existence within it. Nothing inside is waiting to shift into a different form. All of these clues point toward the same quiet conclusion. The photon is not built. It does not resemble a machine with parts or a structure with layers. It behaves as if it is already at the most fundamental level possible, a complete unit with no interior to explore. And yet, something still feels unresolved. Because even if we accept that a photon has no internal structure, another question begins to rise, slowly and naturally, from that realization. Light moves. It oscillates, spreads, carries patterns that repeat and flow through space. Every instrument we build detects this rhythmic behavior, this sense that something is rising and falling as the photon travels. But if there is nothing inside the photon, no components, no internal motion, then what exactly is moving? What is it that vibrates when light vibrates? Hold that question gently, because the answer does not lie inside the photon, but in something far more subtle and far more vast. The deeper we follow this idea, the more the question begins to shift. At first, it seemed like we were searching for something hidden inside the photon, a structure too small to see, a layer too subtle to measure. But every path we've taken has quietly removed that possibility. There is no inner shell, no core, no moving parts waiting to be discovered. So the mystery does not deepen inward. It moves outward. Because if nothing exists inside the photon, then the motion we observe, the oscillation, the rhythm, the wave-like behavior, cannot be coming from within it. And yet, the motion is undeniably real. When a radio antenna receives a signal, something is clearly changing in a steady, repeating pattern. When light passes through a prism, it separates into colors that reflect different frequencies, different rates of oscillation. When lasers emit perfectly ordered beams, the structure of that emission reveals an underlying pattern that repeats with remarkable precision. Something is moving, something is oscillating, but it is not inside the photon. To understand this, we have to gently let go of a familiar image. The idea that a particle must be a tiny object, carrying its own motion within itself. That image works well for everyday objects, and even for many particles we study. But here, it begins to lead us in the wrong direction. Instead, imagine something quieter. Not an object moving through space, but a change passing through something that already exists everywhere. This something is what physicists call the electromagnetic field. But you don't need to think of it as a technical concept. You can imagine it more simply as a continuous presence that fills all of space, even in places that appear completely empty. This field is not made of pieces. It does not sit in one location. It is everywhere at once, like a calm, invisible ocean that extends throughout the universe. And when light travels, it is not an object crossing that ocean. It is a ripple moving through it. This is where the idea begins to settle into place. The photon is not something that contains motion. It is the smallest possible unit of motion within the field itself. Not a carrier of vibration, but the vibration. There are no internal parts rising and falling. No tiny components shifting up and down. The change happens in the field, not inside the photon. This explains something that once seemed contradictory. Why light behaves like both a wave and a particle. Because the field can spread smoothly across space, forming patterns that resemble waves, while the interaction with matter happens in discrete, indivisible steps. The photon is simply the smallest amount of that change that can be transferred at once. This idea first became clear through experiments that seemed almost paradoxical. When scientists reduced the intensity of light to extremely low levels, they expected the signal to fade smoothly, like a dimming wave. But instead, detectors recorded individual, sudden events tiny bursts of energy arriving one at a time. Even when the light was weak, it did not arrive in fractions. It arrived in complete units. At the same time, when that same light was allowed to pass through narrow openings or reflect from thin surfaces, it produced interference patterns, smooth, continuous shapes that only waves were expected to create. Two behaviors, both real, both undeniable. And the only way to resolve them was to accept something unfamiliar. That the photon is not a classical object at all. It does not behave like something with internal structure because it has none. Its identity comes entirely from the field it belongs to. This also explains why increasing the frequency of light increases its energy. Not because the photon contains more stuff, but because the field is changing more rapidly. The oscillation becomes tighter, more compressed in time, and that compression corresponds to a greater transfer of energy when the photon interacts with matter. Nothing inside the photon becomes heavier or more complex. The change exists purely in how the field behaves. And here, another subtle idea emerges. In classical descriptions, we often speak of electric and magnetic components of light as if they are two separate things moving together. It is tempting to imagine them as parts of the photon, perhaps two aspects that combine to form its structure. But this, too, is an illusion created by familiar language. They are not pieces. They are two expressions of the same underlying field, appearing together whenever the field changes. Like two directions of motion within a single ripple, inseparable and always linked. There is still only one thing happening. A single disturbance moving through a continuous field. And the photon is simply the smallest possible version of that disturbance. So the question we carried earlier, what is vibrating when light vibrates, begins to find its answer. Not the photon, not anything inside it, but the field itself. And as this realization settles in, it opens another question, one that feels even more difficult, and yet strangely more natural. If the photon is only a disturbance, if it has no mass, no structure, no internal space, then how can it carry something as tangible, as measurable, as powerful, as energy? Where does that energy exist? If there is nowhere inside the photon for it to be stored? The moment we accept that a photon has no interior, the idea of energy begins to feel different. Because in everything we experience, energy usually belongs to something. A moving object carries energy because of its motion. A compressed spring holds energy because of its shape. A hot object contains energy within the motion of its particles. There is always a place where the energy resides. But the photon gives us no such place. There is no surface to hold it, no interior to store it, no structure to distribute it across. And yet, a single photon can do something remarkable. It can strike an atom and instantly lift an electron into a higher state. It can trigger chemical reactions, can heat matter. It can even begin processes inside stars that shape entire galaxies. So the question becomes unavoidable. If the photon has nowhere to keep energy, how does it carry any at all? The answer begins to form when we return gently to the idea of the field. Earlier, we imagined the electromagnetic field as something like an invisible ocean filling all of space. not made of parts, not confined to regions, but present everywhere, even in what we think of as emptiness. Now imagine that this ocean does not just sit still, can stretch, can curve, can change, and in those changes energy appears, not stored inside an object, but present in the pattern of the field itself. This is a subtle shift in perspective. Energy is no longer something contained. It is something expressed. It exists in the way the field moves, in how quickly it changes, in how tightly its pattern forms and travels. A photon, then, is not carrying energy like a container holds water. It is the movement of the field in a specific way, and that movement is what we recognize as energy. This explains why frequency matters so much. When light has a higher frequency, the field is changing more rapidly. The oscillation becomes faster, more compressed in time. And that increased rate of change corresponds to a greater amount of energy being transferred when the photon interacts with matter. There is no internal mechanism adjusting itself. No hidden engine inside the photon working harder or softer. Only the field changing at different rates. This idea reveals something else that might have seemed mysterious before. Why adding more low-energy light cannot replace a single high-energy photon in certain interactions. For example, if an electron requires a certain threshold of energy to escape from an atom, no amount of low-frequency photons can make that happen, even if they arrive in large numbers. Each photon delivers its energy in one complete step, and if that step is too small, the process simply does not occur. It is not a matter of accumulation. It is a matter of the field reaching the right intensity in a single event. This tells us that the photon's energy is not divisible during interaction. It does not break apart or share itself across multiple outcomes. When the interaction happens, the entire pattern of the field transfers its energy in one unified moment. Again, this points to the absence of internal structure. There are no smaller pieces of energy inside the photon waiting to be distributed. There is only the complete disturbance, delivered all at once. Another quiet implication follows from this. If the energy belongs to the field's motion, and not to any internal mass, then the photon itself does not need weight to carry energy. It does not need substance to perform work. The energy is already present in the field's behavior, and the photon is simply the smallest expression of that behavior in motion. This helps explain something that might otherwise feel impossible. How a massless entity can still exert influence. Because it is not the photon as an object that carries energy. It is the field moving in a way that allows energy to be transferred. And the photon is that movement defined as a single, indivisible event. This perspective also brings clarity to the idea that all photons, regardless of their energy, travel at the same speed. If energy were tied to mass, we might expect higher energy photons to behave differently, perhaps moving faster or slower depending on how much energy they carry. But they do not, because the speed is not determined by the photon itself. It is determined by the field. The electromagnetic field supports only one kind of propagation, one natural speed at which disturbances move through it. And every photon, regardless of frequency, follows that same rule. There is no internal adjustment, no variation based on energy. The field defines the motion completely, so the photon becomes something even more minimal than we first imagined. Not an object with energy inside it, but a pattern of change, where the energy is the change itself. And as this idea settles in, it gently reshapes another assumption we often carry. If a photon has no internal structure, and its energy is not contained within it, then perhaps it also has no clear boundary, no edge where it begins, and no edge where it ends. And that leads us toward another quiet question. If a photon has no size, no surface, no defined shape, then what does it really mean to say that it exists in a particular place? When we try to imagine where a photon is, our intuition begins to struggle, because we are used to objects having boundaries. A stone has a surface. A drop of water has an edge. Even the smallest grains of dust still occupy a clearly defined region in space. You can point to them, locate them, and say with confidence, "It is here and not there." But the photon does not follow this rule. It does not carry a surface. It does not define a boundary. It does not present an edge that separates inside from outside. And yet, it still arrives. It still interacts at a specific place, at a specific moment, delivering its energy with perfect precision. So how can something with no size, no boundary, no defined shape, still appear at a single point when it is detected? To approach this, we return once again to the field. When a photon travels, it is not a tiny bead moving along a path. It is a pattern in the electromagnetic field, and that pattern can extend across a region of space. Not in a vague or undefined way, but in a structured distribution, a spread of possibility. You can imagine it as a gentle presence across space, where the field is slightly disturbed in a particular pattern. This pattern is not confined to a single point, can stretch, expand, and occupy a wide region as it moves. And yet, when the interaction happens, everything changes. The field does not deliver its energy gradually across that entire region. It resolves into a single event, a single location, a single moment where the full energy of the photon is transferred. This is why detection always appears point-like. Not because the photon was a tiny object all along, but because the interaction itself is indivisible. Before the interaction, the photon is not localized in the way we expect. It is spread across the field. After the interaction, the energy is deposited in one place, and the broader pattern is no longer observed. This behavior becomes especially clear in experiments where photons are sent one at a time through narrow openings. Even when released individually, each photon contributes to a pattern that suggests it explored multiple paths simultaneously. The final distribution, built up over many events, forms an interference pattern, something that only makes sense if the photon was not confined to a single trajectory while traveling. But each detection is always a single point. This dual nature can feel unsettling at first. How can something be spread out and yet arrive as a point? How can it occupy a region without having a size? The answer lies in letting go of the idea that existence must always mean occupying a fixed space. For a photon, existence is not about having a shape. It is about the field having a certain pattern. That pattern defines where the photon could interact, not where it is in the classical sense. This is why scientists often speak in terms of probability when describing photons. Not because the photon is uncertain in a vague way, but because the field's disturbance defines a range of possible interaction points, rather than a single fixed location. The photon does not wander randomly. It follows precise rules, encoded in the structure of the field. But those rules describe a distribution, not a pinpoint object. This also explains why no experiment has ever measured a radius of a photon. If it had a physical size, then under the right conditions, that size would reveal itself. Scattering experiments would show deviations. Interactions would depend on how large or small the photon is. At extremely high energies, collisions would expose some finite dimension. But none of this happens. All observations remain consistent with something that has no measurable size at all. Not because it is infinitely small, but because the concept of size simply does not apply. The photon is not a tiny sphere waiting to be measured. It is a distribution of the field, without a boundary that defines where it ends. And this leads to a quiet but powerful realization. When we ask, how big is a photon? We are asking the wrong kind of question. A more meaningful question would be, over what region does the field disturbance extend before interaction occurs? And the answer to that can vary. Sometimes the disturbance may be tightly localized. Other times it may extend across vast distances. In certain controlled systems, a single photon can be spread across lengths that feel almost impossible to imagine, maintaining coherence across those distances until the moment it is finally detected. There is no rigid size that defines it, only the behavior of the field in that moment. So the photon becomes something even more elusive than before. No interior, no stored energy in the traditional sense, no boundary, no size, and yet still capable of interacting with exact precision, still capable of shaping matter, triggering reactions, and carrying information across the universe. At this point, the picture becomes both simpler and more mysterious, because everything we have removed, structure, mass, size, interior, leaves behind something almost pure. A single, minimal expression of change in the electromagnetic field. And that raises a final question for this part, one that lingers quietly as we move forward. If the photon has no structure, no mass, no size, and exists only as a disturbance in a field, could it be the simplest thing that can possibly exist? If we pause here, at the edge of everything we've uncovered, the picture of the photon becomes almost impossibly clean. No internal structure, no mass, no size, no boundary, no internal storage of energy. And yet, it remains one of the most powerful actors in the universe. It travels across unimaginable distances without changing. It carries energy that can shape atoms, ignite stars, and sustain life. It behaves with precision so exact that even the smallest deviation would have revealed itself long ago. So we are left with something that feels both complete and strangely unfinished. Because if the photon is truly this simple, then why does it still carry properties that feel so rich? For example, spin. Even without any internal structure, the photon still possesses a kind of angular momentum. It behaves as if it has a directional twist, something that can influence matter in subtle but measurable ways. When light interacts with certain materials, it can cause tiny rotations, transferring this angular momentum as if something within it were spinning. But there is nothing inside to spin, no surface to rotate, no body to turn, no axis hidden within. And yet the effect is real. This brings us to a deeper shift in understanding. Just as energy was not stored inside the photon, spin is not produced by something rotating within it. Instead, it emerges from the structure of the field itself, from the way the disturbance is shaped as it moves. You can think of it as a kind of twist in the pattern, not a physical rotation of parts, but a directional quality embedded in how the field changes over time. The photon carries this twist naturally, not because it contains something, but because the field supports that kind of behavior. This becomes especially clear when we consider polarization again. The orientation of light is not caused by internal alignment of components. It is a reflection of how the field oscillates in space. And that oscillation can carry direction, even in the absence of structure. So once more, what appears at first to be a property of an object reveals itself as a property of the field. The photon does not own these characteristics. It expresses them. And this pattern continues across everything we've explored. Every time we search for something inside the photon, we find nothing. And every time we observe something about its behavior, we discover that it comes from the field instead. It is as if the photon is not a thing, but a moment when the field carries energy. A moment when the field expresses motion. A moment when the field delivers change. And that moment moves, not because something is traveling through space, but because the pattern itself propagates, unfolding from one region to the next according to the rules of the field. This idea can feel unfamiliar at first, because it challenges the way we usually think about existence. We are used to objects persisting through time, carrying their properties with them as they move from place to place. But the photon suggests something different. It suggests that what persists is not an object, but a pattern that maintains its identity not by holding itself together internally, but by continuously recreating itself as it moves through the field. There is no need for internal stability because there is no interior to stabilize. There is only the consistency of the field's behavior, and that consistency is astonishing. Across billions of years, across extreme environments, across distances so vast they are difficult to comprehend, the photon remains exactly what it is, not because it protects itself from change, but because there is nothing inside it that can be altered in the first place. It is already as simple as it can be. This leads us gently into the final thought for this part. If something has no structure, no components, no internal dynamics, then there is nothing to break, nothing to rearrange, nothing to degrade, and perhaps nothing to simplify further, which raises the quiet possibility that has been forming in the background all along. The photon may not just be a fundamental particle. It may be the closest thing we have ever found to a pure expression of energy itself. Not energy contained, not energy stored, but energy as motion, as change, as a pattern in something deeper. And as we move into the next part, this idea will begin to unfold even further. Because if the photon is truly this simple, this minimal, this close to pure motion, then understanding what is actually moving, what actually twists, what actually gives rise to properties like spin, becomes the next step in our quiet journey. And there, the mystery does not become more complex. It becomes more subtle. At the end of this part, if you're still here with me, gently drifting through these ideas, let me know by leaving a simple 1 in the comments. Just a small signal that you're still listening as the universe slowly reveals how something with nothing inside can still contain everything we see. By now, the question has changed in a quiet but important way. We are no longer asking what a photon is made of, because we have already seen that nothing inside it can be found. Instead, we are asking something more subtle. If the photon is only a disturbance, then what exactly is moving when it travels? Because motion still exists. Light spreads, carries patterns. It arrives from distant stars after journeys that last billions of years. It bends around galaxies, reflects from surfaces, and flows into your eyes in this very moment. Something is clearly propagating through space. But if there is no object, no mass, no internal structure, then what is it that moves? To approach this, we return once more to the field. But this time we look at it more closely, not as an abstract idea, but as something with behavior. The electromagnetic field is not static. It has values at every point in space, and those values can change. At one moment, the field at a particular location may be calm. At the next, it may shift slightly. These changes do not happen randomly. They follow precise rules, unfolding smoothly from one region to the next. When nothing is happening, the field rests in a quiet state. But when a photon appears, that calm is disturbed. Not violently, not chaotically, but in a structured, repeating way. This is what we perceive as a wave. But again, we must be careful with that word, because it can suggest something material rising and falling, like water moving up and down. That image can mislead us. In reality, nothing physical is oscillating up and down. Instead, the value of the field is changing. You can imagine it like this. At one point in space, the field increases slightly, then decreases, then increases again, forming a smooth rhythm over time. Nearby points follow the same pattern, but slightly delayed, so that the pattern appears to move. This moving pattern is what we call light, and the photon is the smallest possible piece of that moving pattern. So when we ask what is moving, the answer becomes clearer. Not a particle, not a tiny object traveling through empty space, but a pattern of change passing through a field that already exists everywhere. This is why the photon does not need mass to move. It is not being pushed or pulled like an object. It is not accelerating or slowing down. It simply follows the natural way that changes propagate through the field. And that propagation has a fixed speed, not because of the photon itself, but because of the field. The electromagnetic field allows disturbances to travel in only one way, at one speed. Every photon, regardless of its energy, follows this same rule. There is no variation, no adjustment, no internal mechanism controlling the motion. The pattern moves, because that is how the field behaves. This also explains why nothing inside the photon can be found. Because there is no inside to begin with. There is only the pattern and the field in which it exists. Now, as this idea settles, something else begins to come into focus. If the photon is a moving pattern, and if that pattern has direction, orientation, and properties like spin, then those properties must also come from the structure of the pattern itself. Not from hidden components, not from internal rotation, but from how the field is changing as the pattern moves. This becomes especially interesting when we think about polarization again. The photon can carry a specific orientation, a direction in which the field changes as it propagates. That orientation can remain stable across vast distances, as if the pattern itself remembers its shape. But nothing is storing that memory. There is no internal structure preserving it. The stability comes entirely from the rules of the field. Once the pattern is formed, it continues to evolve in a consistent way, maintaining its structure because the field itself enforces that consistency. It is not being held together. It is simply unfolding according to the same rules at every point along its path. And here, a deeper realization begins to emerge. The photon is not something that travels through space. It is something that is the travel. The motion is not something it does. The motion is what it is. A continuous unfolding of change, moving from one region of the field to the next, carrying energy not as a stored quantity, but as the very expression of that change. And this leads us naturally to the next layer of the mystery. Because if the photon is a pattern in motion, and if nothing inside it is rotating, then what does it really mean to say that it has spin? What exactly is twisting in something that has no body at all? When we hear that a photon has spin, something in our intuition immediately reaches for a familiar image. We imagine rotation, a tiny sphere turning in place, a miniature object spinning around an axis, like a planet or a top. That image feels natural, almost unavoidable, because in our everyday world, spin always comes from something physically rotating. But here, that picture quietly breaks apart, because the photon has no surface to turn, no mass to rotate, no internal structure that could even define an axis. And yet, the spin is real, can be measured, can be transferred. It can influence matter in precise and predictable ways. When light interacts with certain materials, it can cause tiny rotations, as if something within it carried angular momentum. So the question becomes more refined. If nothing inside the photon is spinning, what exactly is this spin? The answer begins once again in the field. Just as energy was not stored inside the photon, and motion was not carried by a moving object, spin is not the result of physical rotation. It is a property of how the field is structured as it changes. To sense this more clearly, imagine the field not just rising and falling, but doing so with a kind of directional twist. At each point in space, the field does not simply oscillate back and forth. It can oscillate in a way that traces a circular or helical pattern over time. Not a physical circle drawn in space, but a cycle of change that has direction built into it. This directional change, this sense of rotation within the pattern, is what we perceive as spin. Nothing is turning, but the pattern has a twist, and that twist carries angular momentum, even though no object is rotating. This becomes easier to feel when we think about polarization in a slightly different way. Instead of imagining it as a fixed direction, imagine the field's oscillation tracing a gentle spiral as the photon moves forward. Depending on how that spiral is oriented, the photon can carry one form of spin or another. These two possibilities correspond to what physicists call helicity. But you don't need the term to understand the idea. The photon can twist in one direction or the opposite direction as it moves. That is all. There is no third option where the twist disappears entirely. And this, too, is not an arbitrary limitation. It comes from the nature of the photon itself. Because the photon has no mass, it cannot be brought to rest. It always moves at the same speed. And because it cannot stop, there is no frame of reference in which the twist could appear differently. The pattern is always tied to its motion, so only two orientations remain possible. Two ways the pattern can twist as it travels. And this is what we observe as spin. Again, the simplicity is striking. What once seemed like a property of an object reveals itself as a feature of a pattern. No internal machinery, no rotating parts, only the structure of the field unfolding in a specific way. This idea has been tested in subtle but convincing ways. When light with a particular polarization interacts with small particles, those particles can begin to rotate. Not because the photon itself is spinning like a tiny wheel, but because the pattern of the field transfers its angular momentum during the interaction. The rotation we observe belongs to the particle that receives the energy, not to something spinning inside the photon. The photon simply carries the pattern, and when that pattern is absorbed, its properties are expressed in the motion of matter. This brings us back to something we've seen before. The photon does not contain its properties. It expresses them. Everything about it, energy, motion, spin, arises from how the field behaves. And nothing about it requires internal structure. Now, as we let this settle, another layer begins to appear. If spin is not rotation, if motion is not movement of an object, if energy is not stored inside, then nearly everything we associate with particles must be reinterpreted, not as things that belong to an object, but as features of a pattern. And that realization leads us gently toward another question. Because if the photon carries angular momentum without rotating, and energy without mass, then how do these properties come together in a way that allows the photon to interact so precisely with matter? How does a pattern, something with no substance, produce effects that are so exact, so consistent, so measurable? And perhaps more quietly, where does all of this reality exist, if it is not inside the photon at all? As we continue to follow this idea, something subtle begins to take shape. If the photon is not an object, but a pattern in a field, then its interaction with matter becomes one of the most important clues we have. Because whatever the photon truly is, it must explain how that interaction happens with such precision. When a photon meets an electron inside an atom, something very specific occurs. The electron does not absorb part of the photon. It does not gradually take in energy over time. Instead, the interaction happens all at once in a single complete step. Either the photon is absorbed, or it is not. There is no middle state. This behavior tells us something important. The photon cannot be divided during interaction, cannot partially exist, cannot spread its energy across multiple outcomes in that moment. And yet, before that interaction happens, it behaves as if it is spread out across space. So we are left with a quiet contrast, a spread out pattern that resolves into a single event. To understand this, we need to look carefully at what interaction really means. When the photon is traveling, it is a pattern in the electromagnetic field. That pattern extends across space, defining a range of possible places where an interaction could occur. Not a random range, but a structured one shaped by the way the field evolves. This is sometimes described as a distribution of likelihood, but we can think of it more gently as a map of where the photon could complete its journey. And then, at a certain moment, the field interacts with matter, and everything becomes localized. The entire pattern collapses into a single outcome, not because something inside the photon moved into place, but because the interaction itself selects one possibility from the pattern. The photon does not shrink. It does not travel into a point. The pattern simply resolves. And in that resolution, the full energy of the photon is delivered. This helps explain why the photon always behaves as a complete unit during interaction. There are no smaller pieces to distribute, no internal structure to divide. The field transfers its energy in the smallest possible step, and that step is indivisible. But there is another layer here that deepens the picture. The interaction is not something the photon does alone. It is a relationship between the field and matter. The electron, for example, is not a tiny object waiting passively. It is itself a pattern in another field with its own structure, its own allowed states, its own rules for how it can change. When the photon arrives, the interaction only occurs if the pattern of the electromagnetic field matches what the electron can accept. If the energy is too low, nothing happens. If the pattern does not align, nothing happens. Only when the conditions are exactly right does the interaction take place. And when it does, it is immediate. There is no delay, no gradual buildup, no sense of the electron collecting energy over time. The field transitions from one state to another in a single step, and the photon as a pattern is no longer present in the same form. It has not been broken apart. It has not been consumed piece by piece. It has simply completed its role as a transfer of energy within the field. This perspective shifts how we think about cause and effect at the smallest scales. We are not watching objects collide. We are watching patterns interact. Patterns that exist within fields, following rules that determine how those fields can change. And this is why the photon can produce such precise outcomes. Because its behavior is not governed by internal complexity. It is governed by the structure of the field itself, which operates with exact consistency. There are no hidden variables inside the photon that could introduce variation. No internal mechanisms that could behave unpredictably. Everything about the interaction is defined by the relationship between field patterns. And that relationship is exact. This also explains why the photon does not lose energy during travel. As it moves through space, it does not gradually weaken like a physical object wearing down over time. There is no internal structure to degrade, no energy reservoir to leak. The pattern simply continues unchanged until it interacts. Only then is the energy transferred, and until that moment, the photon remains complete. This idea brings us closer to something that feels almost paradoxical. The photon is both extended and indivisible. It spreads across space, yet acts as a single unit. It behaves like a wave, yet interacts like a particle. But now, these are no longer contradictions. They are two aspects of the same underlying truth. The field spreads. The interaction is discrete. And the photon exists exactly at the boundary between those two behaviors, not as a compromise, but as a perfect expression of both. As this becomes clearer, another question begins to form. If the photon is defined entirely by the field, and if its interaction depends on matching patterns with matter, then what determines the exact amount of energy it carries? Why is that energy always precise, always consistent, never slightly more or slightly less? And how does that precision arise? From something with no internal structure at all? The more we follow the photon, the more it reveals a kind of precision that feels almost quiet, almost hidden beneath its simplicity, and yet this precision is absolute, unyielding, and present in every interaction it makes across the universe, because no photon ever arrives with almost the right energy, no photon ever delivers close enough, and no photon ever seems to hesitate between two possibilities. It either matches exactly, or nothing happens at all, and this sharp boundary between interaction and non-interaction is one of the clearest signs that something deeper is governing its behavior, something that does not allow gradual adjustment or internal variation, something that enforces exactness from the very beginning of the photon's existence. And to understand this, we have to return again to the idea that the photon is not carrying energy like an object carries weight, but is instead defined entirely by a pattern in the field, because if the photon is a pattern, then its energy is not something it holds, but something that is inseparable from the pattern itself. And this means the energy cannot vary independently, it cannot drift, it cannot slowly change as it travels, because that would require the pattern to change. And if the pattern changed, the photon would no longer be the same photon, so the energy is fixed not by storage, but by identity, by the very shape of the disturbance in the field. And this is why every photon is born with a precise amount of energy tied directly to how rapidly the field is changing within that pattern. A faster change corresponds to a higher energy. A slower change corresponds to a lower one. and there is no room in between for ambiguity because the field does not allow partial patterns, it allows only complete ones, and this leads to something subtle but powerful. The idea that the photon's energy is quantized not because someone imposed a rule on it, but because the field itself only supports certain kinds of change, like a musical instrument that can produce only specific notes depending on how it is shaped. The electromagnetic field can only express energy in discrete units when it interacts, and the photon is that unit, the smallest complete note the field can play, and this helps explain why energy transfer is always exact. Because when the photon interacts, the field does not gradually shift into a new state. It transitions completely, like a sudden change in a pattern that cannot exist halfway between two forms, and this is why electrons respond so sharply, because they too exist in patterns that only allow specific transitions. So when the photon arrives, the interaction is not a negotiation. It is a match. Either the patterns align and the transition happens instantly, or they do not align and nothing occurs. And this matching is what gives the photon its remarkable precision. Not because the photon is carefully calibrated, but because the field itself enforces exact relationships between patterns, and as we begin to see this more clearly, something else begins to emerge. Something that feels almost philosophical, because if the photon's energy is defined entirely by its pattern, and if that pattern cannot change without ceasing to be what it is, then the photon carries its identity through space in a way that does not depend on anything internal. It does not need to preserve structure. It does not need to maintain stability. It simply continues to exist as the same pattern, unfolding step by step through the field, and this unfolding is perfectly consistent, because the rules governing the field do not vary from place to place, they do not weaken over distance, they do not degrade over time, so a photon traveling for billions of years remains exactly what it was at the moment it was created, not because it protects itself, but because there is nothing inside it that could be altered, and this idea becomes even more striking when we consider that the photon does not gradually lose energy as it moves. There is no internal reservoir that drains, no friction that wears it down. The energy remains part of the pattern until the moment of interaction, and only then is it transferred completely. And this reinforces the idea that the photon is not carrying energy through space in the way we imagine objects carrying things, but is instead the continuous presence of that energy as a moving pattern. And so the precision we observe is not something the photon achieves. It is something it cannot avoid, because there is no mechanism within it that could introduce variation, no internal freedom that could allow deviation. Only the exact expression of the field's behavior at every point along its path. And this brings us to a deeper realization that what we are observing is not just a particle behaving simply, but a fundamental rule of nature expressing itself in its most minimal form. The photon is not complex because it does not need to be. It is not flexible because it cannot be. It is exactly what it is at every moment without adjustment or change, and as this idea settles, it leads us gently toward another question, one that feels almost inevitable now, because if the photon's identity is completely defined by its pattern, and if that pattern determines its energy, its motion, and its interactions, then what determines the form of that pattern in the first place? What shapes it? What defines its structure? And why does the field allow this particular kind of disturbance, and no simpler one? As we reach the final layer of this part, the question becomes quieter, but deeper than before, because everything we have uncovered keeps pointing in the same direction, gently removing the idea of the photon as a thing, and replacing it with something far more subtle, something that does not sit in space, does not carry parts, does not hold energy inside, and yet still behaves with perfect consistency across the entire universe. And now we are left with a question that feels almost foundational, not just about photons, but about reality itself, because if the photon is only a pattern in a field, then what determines that pattern, what gives it its exact form, and why does the field allow this specific kind of disturbance to exist, and no simpler one, because it might seem at first that a pattern could take any shape, that the field could ripple in infinitely many ways, but this is not what we observe. Instead, we see something very constrained, very precise. The photon always appears as the smallest possible unit of electromagnetic change, never smaller, never divided, never partially formed, and this suggests that the field itself has limits, not imposed from outside, but built into its nature, limits on how it can change, how it can evolve, and how energy can move within it. And these limits are what give rise to the photon, not as a constructed object, but as the most minimal expression of what the field can do. And this idea can be felt more clearly if we imagine trying to create a disturbance smaller than a photon, a weaker pattern, a softer change, something that carries less than the smallest unit of energy. But every attempt to imagine this begins to dissolve, because such a disturbance would not be stable, it would not persist, it would not interact in a meaningful way, it would simply fade back into the quiet state of the field without ever becoming a complete event. And this is why the photon appears as a threshold, the point at which a disturbance becomes real enough to travel, real enough to interact, real enough to be observed, and below that threshold, there is no smaller photon, no partial unit waiting to be discovered, only the absence of a complete pattern. And this is what gives the photon its unique role. It is not just the simplest particle we know. It is the simplest possible change that still counts as something, the smallest event that the field can sustain. And this idea carries a quiet elegance because it suggests that the universe does not build everything from smaller and smaller pieces endlessly, but instead reaches a point where the concept of smaller no longer applies, where what remains is not a fragment, but a fundamental unit of change, and the photon sits exactly at that boundary, not as a building block in the traditional sense, but as a minimal expression of activity. And this also explains why the photon can be created and destroyed so freely, because it is not preserving an internal structure that needs to be maintained. It is simply the field shifting from one state to another. And when that shift occurs, a photon appears, and when the energy is transferred, the photon is no longer present in the same form, not because it has been broken apart, but because the pattern has completed its role, and this constant appearing and disappearing does not violate anything. Because nothing is being taken apart, nothing is being lost, only the field changing its configuration. And in this sense, the photon is less like an object traveling through space, and more like a moment of change moving through time, a transition that carries energy from one place to another without ever needing to exist as a physical thing in the way we usually imagine. And as we let this idea settle, something else begins to feel clearer, something that has been quietly present throughout the entire journey, the realization that the photon does not exist independently of the field. It cannot be separated from it, cannot be isolated from it, because it is not something within the field, it is something the field is doing, and this dissolves one of the last remaining intuitions we might still be holding, the idea that space is empty and photons travel through it, because if the field is everywhere, and the photon is a pattern in that field, then there is no empty space for the photon to move through, only the field itself, continuously present, continuously capable of change, and the photon is one of the simplest ways that change can occur, And so the journey we began with, asking what a photon is made of, now feels almost complete, because the answer is not hidden inside the photon. It was never there. The answer lies in the field, in its structure, in its limits, and in the patterns it allows to exist. And the photon is one of those patterns, perhaps the simplest. One we can observe, and yet still rich enough to carry energy, to shape matter, and to connect distant parts of the universe through a single, continuous expression of change. And as we prepare to move into the final part, one last question begins to rise, soft but persistent, because if the photon is the simplest possible expression of energy in motion, then what does that tell us about everything else, about matter, about particles with mass, about the structures that seem so much more complex? Could they, too, be nothing more than patterns in deeper fields, shaped by rules we are only beginning to understand? And if so, then the photon is not just a mystery on its own, but a doorway, a quiet introduction to a universe where everything is not built from things, but from patterns of change unfolding in fields that fill all of reality. At the end of this part, if you are still here, still drifting with these ideas, gently leave a 2 in the comments. Just a small sign that you are still listening as we move into the final layer of this cosmic story. As we enter this final part, the idea of the photon begins to settle into something almost quiet, almost still, even though it represents motion itself, because by now we have slowly removed everything that once made it feel familiar. We have taken away its mass, its size, its internal structure, its boundaries, and even the idea that it is an object moving through space. And what remains is something that does not behave like a thing at all, but like a pure event, a minimal expression of change in a field that exists everywhere. And this is where the question becomes less about the photon itself and more about what it reveals. Because if something so simple can carry energy, can travel across the universe unchanged, can interact with perfect precision, then perhaps simplicity is not a limitation but a foundation, and the photon may be showing us what reality looks like at its most reduced form, not built from parts, but arising from patterns that cannot be simplified any further. And this becomes especially clear when we consider the way photons behave under the most extreme conditions the universe can provide. Because if there were any hidden structure inside the photon, any internal feature that could be stretched, distorted, or broken, those conditions would reveal it. And yet again and again, across every environment we can observe, the photon remains unchanged. It passes through regions of intense gravity, where space itself is curved, and its path bends smoothly without any sign of internal strain. It moves through dense plasma where charged particles create chaotic electromagnetic conditions, and yet its fundamental behavior remains stable. It emerges from violent cosmic events, carrying enormous amounts of energy, and still shows no sign of internal complexity. And this consistency is not just remarkable, it is deeply informative, because it tells us that the photon has nothing inside it that can be altered, nothing that can respond differently under stress, nothing that can break or deform. And this is why it survives journeys that would destroy any structured object, because there is no structure to destroy, only a pattern that continues to unfold according to the same rules everywhere in the universe. And this leads us to a realization that feels both simple and profound. The photon does not endure because it is strong. It endures because it is minimal, because there is nothing within it that can fail. And this idea becomes even clearer when we think about how other particles behave, because particles that have mass, that have more complex identities, often reveal internal dynamics under extreme conditions. They can decay, they can transform, they can interact in ways that expose deeper layers of structure. But the photon does none of this. It remains exactly what it is, regardless of where it travels or how long its journey lasts. And this makes it unique, not just as a particle, but as an example of how simple something can be while still playing a central role in the universe. And this simplicity also explains why the photon can be created and destroyed so freely, because it is not preserving a structure that needs to remain intact. It is simply the field shifting from one configuration to another, and when that shift happens, a photon appears, and when the energy is transferred, the photon is no longer present, and nothing has been broken, nothing has been lost, only the pattern has changed. And this idea quietly reshapes how we think about existence itself, because it suggests that what we often call things may not be things at all, but stable patterns in underlying fields, patterns that persist because the rules of the field allow them to persist. And the photon is the simplest example of this, the smallest stable pattern that can carry energy across space. And as we sit with this idea, something else begins to emerge, something that connects back to one of the earliest questions we asked. If the photon has no interior, no structure, no size, and exists only as a pattern, then what does it really mean to say that it exists at all? Is it something that travels, or is it something that happens? And this distinction may seem subtle, but it changes everything. Because if the photon is not an object moving from one place to another, but a continuous unfolding of a pattern through the field, then its existence is not tied to a location, but to a process that begins when the field changes in a particular way, and ends when that change is absorbed or transformed, and in between, what we perceive as the photon is simply the ongoing expression of that change. And this leads us toward one of the most important realizations of all. The photon is not a thing that carries energy through space. It is energy moving through space, not contained, not stored, but expressed as a pattern that persists until it completes its role. And as we move deeper into this final part, this idea will begin to connect with everything else we have explored, from energy and motion to spin and interaction, and we will begin to see how all of these pieces fit together into a single, coherent picture, one where the photon is not just a particle but a window into the fundamental nature of reality itself. As this idea continues to unfold, something very quiet begins to become clear, something that does not feel dramatic, but slowly reshapes how we understand not just the photon, but everything around it. Because if the photon is not a thing, not an object, not a structure, but a process, then many of the assumptions we carry about reality begin to soften. And one of those assumptions is the idea that energy must exist somewhere, that it must be located, stored, or contained within something, because this is how we experience energy in everyday life. We see it in moving objects, in heat, in pressure, in stored tension. But the photon shows us something different. It shows us that energy does not need a container. It does not need a place to reside. It can exist purely as motion, purely as change, purely as the behavior of a field unfolding over time. And this is why the photon can carry energy across billions of years without losing anything, because there is nothing inside it to degrade, nothing to leak, nothing to wear down. The energy is not something it holds, it is something it is. And as long as the pattern continues, the energy remains exactly as it was at the moment the photon came into existence. And this leads to a realization that feels almost counterintuitive. The photon does not transport energy through space in the way we imagine a package being carried from one place to another. Instead, the energy is continuously present in the field as the pattern moves. It is not being moved from point A to point B as a stored object, but expressed along the path of the pattern itself. And this is why the photon can arrive at a detector after billions of years and still deliver its energy in one complete, precise moment. Because the energy was never stored inside it in the first place, it was always part of the field's motion. And the photon is simply the trace of that motion as it unfolds. And this perspective also helps us understand something that once felt deeply strange, the idea that photons of different energies all travel at the same speed. Because if energy were tied to mass or internal structure, we might expect differences. We might expect heavier or more energetic photons to behave differently. But they do not, because the speed is not determined by the photon as an object. It is determined by the field itself. The electromagnetic field allows only one way for disturbances to propagate, and every photon follows that same rule, regardless of how much energy its pattern carries. And so once again, what seemed like a property of the photon reveals itself as a property of the field, and the photon becomes less and less like an independent entity, and more like a reflection of how the field behaves under certain conditions. And this leads us to another subtle point, one that connects to everything we have explored so far. Because if the photon has no size, no boundary, and exists as a spread-out pattern before interaction, then its location is not something fixed. It is not sitting at a single point as it travels. Instead, its presence is distributed across space, defined by where the pattern extends, and only when interaction occurs does that distribution resolve into a single event. And this means that the photon's journey is not a path traced by a tiny object, but a continuous unfolding of possibilities within the field, narrowing into a single outcome only at the moment of interaction. And this idea can feel abstract, but it carries a deep consistency, because it explains why we can never measure a photon's exact position and path at the same time, why its behavior appears spread out during travel but precise at detection, and why no experiment has ever revealed a definite boundary for it. And as we let this settle, something even more fundamental begins to emerge, the realization that the photon may not just be simple, but maximally simple, meaning that it cannot be reduced any further without ceasing to exist as something observable, because we have already removed everything that could be taken away, and what remains is a pattern that exists only as long as the field continues to express it. And this places the photon in a unique position within our understanding of the universe. It is not just one particle among many, it is a kind of baseline, a reference point for what it means for energy to exist in its most minimal form. And when we compare it to other particles, especially those with mass, the contrast becomes even more striking, because those particles often involve more complex field configurations, more internal relationships, more ways to interact and transform. But the photon does not. It remains unchanged, not because it resists change, but because there is nothing within it that can change. And this simplicity is not a limitation, it is a kind of purity, a direct expression of the field's behavior without any added structure. And as we continue moving forward, this idea will begin to connect with the broader question that has been quietly forming in the background. Because if the photon represents the simplest possible pattern in one field, then perhaps other particles represent more complex patterns in other fields. And if that is true, then what we call matter may not be made of solid pieces at all, but of stable patterns, sustained by the rules of deeper fields that we are only beginning to understand. And in that sense, the photon is not just a mystery to be solved. It is a guide, a starting point, a glimpse into a way of thinking where everything we see is not built from things, but from patterns of change unfolding across a universe that is far more continuous, far more subtle, and far more interconnected than it first appears. As we continue drifting deeper into this idea, something begins to feel almost inevitable, as if all the threads we have followed are slowly weaving into a single, quiet conclusion, because every path has led us away from objects and toward patterns, away from structure and toward behavior, away from things that exist in space and toward processes that unfold through it, and the photon, in its simplicity, becomes the clearest example of this shift, because it does not resist this interpretation. It almost invites it. It removes every feature that would allow us to hold on to the idea of a physical object, until what remains is something that feels less like a particle and more like a pure expression of the universe's underlying rules. And this is where we can begin to look outward, beyond the photon itself, and ask a broader question, one that has been quietly waiting in the background, because if the photon is a pattern in a field, and if its simplicity represents the most minimal form of that pattern, then what about everything else? What about electrons, atoms, stars, even ourselves? Could they too be patterns, more complex, more stable, but still rooted in the same underlying idea? And this possibility is not just philosophical, it is deeply connected to how modern physics describes reality. Because in that view, every particle is associated with a field, and what we call a particle is simply a stable excitation of that field, a pattern that persists, and the photon is the simplest of these, the cleanest example, the one with nothing extra added. And this is why it becomes so important, not because it is mysterious, but because it is transparent. It shows us the structure of the theory without complication. It shows us what remains when everything unnecessary is removed. And in doing so, it gives us a glimpse of how more complex particles might arise, not as collections of smaller pieces, but as richer patterns in different fields, patterns that can hold together, that can maintain identity, that can interact in more varied ways. And this leads us to one of the most intriguing ideas that has been explored over time, the possibility that what we think of as distinct particles might not be fundamentally different kinds of things, but different configurations of underlying fields. And in some speculative models, even the electron has been imagined as a kind of trapped or circulating pattern of electromagnetic energy, not something made of different material, but something that emerges when a pattern becomes confined and self-sustaining. And while such ideas are not part of the standard understanding, they highlight something important. They show how the simplicity of the photon invites us to imagine how complexity might arise from it, not by adding pieces, but by shaping patterns in new ways. And even if these models are not correct in detail, they still point toward a deeper intuition that the universe may not be built from solid building blocks at all, but from dynamic structures, patterns that hold their form because the rules of the fields allow them to. And this brings us back to the photon with a new perspective, because now it is not just the simplest particle, it is the simplest pattern, the baseline from which we can begin to understand everything else. And this simplicity also explains why it behaves the same everywhere, why it shows no variation, no internal degrees of freedom, no hidden complexity, because there is nothing to vary, nothing to rearrange, nothing to adjust. It is already at the limit of simplicity. And this is why it travels unchanged across the universe, why it survives conditions that would disrupt any structured system, why it arrives exactly as it began, not because it protects itself, but because there is nothing within it that could be altered. And as we let this settle, something almost peaceful begins to emerge, the realization that the photon does not need to be understood in terms of parts or mechanisms or internal processes. It can be understood as a direct expression of how the universe allows energy to move, a simple, elegant, and complete answer to a very deep question. And yet even here, one final layer remains, one last quiet shift in perspective. Because if everything we have said is true, if the photon is not an object but a pattern, not a thing but a process, then perhaps the most important question is not what the photon is, but what it reveals about the nature of reality itself, because it suggests that at the deepest level, the universe is not made of things that exist independently, but of relationships, of interactions, of patterns that only exist through their connection to the fields that support them. And in that sense, the photon is not just part of the universe. It is a glimpse of how the universe works, a small, simple window into a much larger and more subtle truth. As we move into this final stretch, everything begins to slow down. Not because there is less to understand, but because what remains is no longer about adding new ideas. It is about letting the simplest idea settle fully into place, because after everything we have explored, every layer we have gently removed, every assumption we have allowed to fade, we are left with something that is almost impossibly minimal, something that does not demand effort to hold on to, but instead asks us to release. The need to imagine it as a thing at all, and in that quiet space, the photon begins to feel less like a mystery to solve and more like a presence to understand. Because it shows us that reality at its deepest level may not be built from objects, but from events, from processes, from patterns that arise and fade within fields that are always there, always present, even when nothing seems to be happening. And this is where one final shift in perspective becomes important, because instead of asking where the photon is or what it is made of, we begin to ask when it is, because its existence is tied to a process that unfolds over time. It begins when the field changes in a specific way, it continues as that change propagates, and it ends when the energy is transferred and the pattern no longer persists in the same form. And in that sense, the photon is not something that exists continuously in space, but something that exists continuously in motion, a process that cannot be separated from the act of moving itself. And this is why it cannot be at rest, why it cannot be slowed down, why it cannot be paused or held in place, because to stop the motion would be to remove the pattern, and to remove the pattern would be to remove the photon entirely. And this idea, though simple, carries a kind of quiet depth, because it suggests that motion is not something added to the photon, it is what defines it, and without motion, there is nothing left. And as we sit with this, another realization begins to emerge, one that connects back to everything we have seen about energy. Because if the photon is motion, and if its energy is the expression of that motion, then energy itself may not be something that exists independently, but something that only appears when change is occurring, something that is inseparable from the process of transformation. And this aligns with what we have observed all along, that the photon does not carry energy as a stored quantity, but expresses it through its existence as a moving pattern. And when that motion ends, when the pattern resolves through interaction, the energy does not disappear, it simply takes on a new form within the field or within matter. And so nothing is lost, nothing is broken, only the pattern changes. And this brings a kind of continuity to the entire picture, a sense that the photon is part of an ongoing flow, not an isolated object traveling through empty space, but a moment in a continuous process that connects emission and absorption across vast distances. And in this way, the photon becomes less like a messenger carrying information, and more like the connection itself, the link between two events, the bridge between one change in the field and another. And this perspective also softens one of the last remaining questions we might hold, the question of where the photon goes when it is absorbed. Because if the photon is not an object, then it does not go anywhere, it does not move. into the electron or disappear into some hidden space. Instead, the pattern that defined it simply ends, and the energy that was expressed in that pattern becomes part of a new pattern, a new configuration of the field or of matter. And so the photon does not vanish, it transforms not by breaking apart, but by completing its role in the continuous unfolding of the field. And this idea, when allowed to settle, brings a kind of calm clarity, because it removes the need to imagine hidden processes or invisible structures. It replaces them with a simple, consistent picture, one where everything is part of a continuous flow of change, and the photon is one of the simplest expressions of that flow. And as we approach the very end of this journey, one final thought begins to take shape, a thought that does not demand an answer, but invites reflection. Because if the photon is the simplest possible expression of energy in motion, if it is a pattern that cannot be reduced any further, then perhaps it is not just a building block of the universe, but a glimpse of the rules that give rise to everything, a quiet hint that beneath all complexity, beneath all structure, beneath all forms, there is something profoundly simple, something that does not need to be constructed, something that simply happens again and again everywhere in the universe in the form of patterns that move, interact, and transform. And the photon is one of those patterns, perhaps the clearest one we have ever observed. And now, as everything begins to slow, we arrive at the quiet edge of the journey, not with a sudden answer, but with a gentle clarity that has been forming all along, because the question we started with, what is a photon made of, has slowly dissolved, not into a more complicated explanation, but into something simpler than we expected, something that does not require us to look deeper inside, but instead to look differently at what inside even means, because the photon has shown us, step by step, that there may be nothing there to find, no hidden structure, no smaller pieces waiting beneath the surface, no internal machinery shaping its behavior. And instead, what we have discovered is something that does not live inside the photon at all, but surrounds it, defines it, and gives rise to it, the field, the quiet, continuous presence that fills all of space. And within that field, the photon is not a thing but a moment, not an object but a process, not something that exists on its own, but something that happens when the field changes in a specific minimal way. And this shift in perspective, though subtle, changes everything, because it suggests that the search for deeper layers may not always lead to smaller components, but sometimes leads to simpler patterns, and the photon may be one of those final steps, a place where the idea of made of simply no longer applies, because there is nothing left to break apart, nothing left to reduce, only a pattern that exists as long as it is unfolding, and then transforms into something else when that unfolding completes. And this idea, once it settles, carries a kind of calm with it, because it removes the need to imagine hidden complexity. It replaces it with a sense of continuity, a sense that everything we observe is part of a larger flow, a flow where patterns emerge, move, interact, and dissolve, without ever needing to be built from solid pieces. And the photon becomes one of the clearest examples of this, not because it is complex, but because it is not, because it stands at the boundary where our intuition about objects no longer applies, and where a new way of understanding begins to take shape. And as we reflect on this, something else quietly follows, a thought that extends beyond the photon itself. Because if one of the most fundamental carriers of energy in the universe is not a thing but a pattern, then perhaps many of the things we take for granted as solid, as stable, as independent, may also be patterns at a deeper level, more complex, more layered, but still rooted in the same underlying idea. And this does not make them less real, It makes them differently real as processes, as relationships, as structures that persist because the rules of the fields allow them to persist. And in that sense, the photon is not just a mystery to understand, it is an introduction, a quiet invitation to see reality in a new way, not as a collection of objects, but as a tapestry of patterns, each one arising, evolving, and fading within a universe that is far more continuous and interconnected than it first appears. And as we come to the end of this journey, there is no need to hold on to every detail, no need to resolve every question completely, because the value of this exploration is not in reaching a final conclusion, but in allowing the perspective to shift, even slightly, even gently, and perhaps as you rest, as you drift between thoughts, this idea can remain with you, not as something to analyze, but as something to feel, the quiet possibility that at the deepest level, the universe is not built from things, but from simple, elegant patterns of change, unfolding endlessly across the vastness of space. And among those patterns, the photon moves, not as an object traveling through emptiness, but as a trace of motion itself, a whisper of energy passing through the field, connecting distant parts of the universe in a way that requires no structure, no boundary, and no inside at all. And if you are still here, still listening as everything slows into silence, gently leave a 3 in the comments. Just a small signal that you have reached the end of this quiet journey with me. And as the ideas begin to fade into the background, let your thoughts soften. Let the questions rest, and allow yourself to drift, knowing that somewhere, even now, photons are traveling across the universe, carrying nothing inside them, and yet shaping everything you see.